Welcome, everyone, to the Oilfield Water 360 podcast. I'm Danny Grant, Vice President of Technology for Select Water Solutions.
And I'm Michael Skarke, Chief Operating Officer for Select Water Solutions.
Michael, we've both been in the industry for going on 2 decades now, and a lot has changed. So what would you say the biggest changes are coming up with the water infrastructure and water management?
Just think about all we've seen in the last 20 years in the industry. I mean, it's been incredible, from efficiencies in drilling, in frac, certainly in water. The progress we've made as an industry is just remarkable. I mean, we've been able to produce so much more oil and so much more gas at a cheaper cost seemingly every year. And that is certainly true for kind of the water midstream segment. We're handling more volumes than we ever have before. I mean, in terms of longer laterals, average volume per stage, the amount of stages, that's on the frac side. And then you think about the produced water as we move into tier 2 and tier 3 acreage and you get higher water cuts. It's a constantly evolving challenge, and the industry's done a great job at continuing to not only meet that challenge, but do so in a manner that is more cost effective than we were doing it a couple of years ago.
And we've done a lot of that with technology, right? Automating things, giving visibility to central locations. Is that a trend that you see continuing? Do you think we're going to continue to drive those efficiencies out like that?
I mean, technology is going to be a bigger and bigger part of it. I mean, in the way we're managing data, the data points we're collecting, and you certainly can see that and can talk about it. It's truly exponential. And I think the technology has been the biggest reason we've been able to reduce the cost and increase performance over the last few years. And you think about, again, going back to drilling, to frac, to the big ticket spend items, the improvements there are incredible. But going back to water for a minute, when you think about all the different data captures we have along that process, when you talk about balancing the long and shorts for an operator from an integrated water network, you can't do it without technology. You physically can't have people out there turning valves and managing the flow of water and flowing back from 10 different operators into a water treatment facility and then dispersing that to a single operator for a trimul-frac. It's just the volumes are too high. So we have to lean on technology, we have to lean on automation, and that's what enables us to make a very effective water network. That's what enables us to balance the water. And that's really the rise of water midstream. And water midstream is not, to me, it's not just moving water in pipe more efficiently than you can move it above ground or in trucks. It's about an integrated network that takes care of all your water needs, whether that's frac water delivery or produced water recovery, recycling, or disposal.
So do you think we're going to see the growth is going to continue in the water network delivery? How much more can it grow?
I mean, the first thing I know is the amount of efficiency and the level of efficiency we're going to see is going to continue to increase and will surprise everyone. I think back a couple of years ago, and I can't remember if it was Marshall Atkins or someone else, and they were talking about how the one thing they had confidence in was the continued improvement of efficiency and the innovation of our industry. And so you look now at we're drilling U-shape wells. I mean, that just defies logic of 10 years ago. And so I think as we look forward, you're going to continue to see efficiencies, some of which are fairly obvious, like moving towards beneficial reuse solutions and away from disposal. And some are solutions that we probably don't have great visibility in today. From a water midstream standpoint, to kind of get to your question directly, we're going to have to be more networked. The more customers you can have on a single network that can move water multiple directions at the same time, the more likely you are to be efficient with every single barrel of water. And that's really our goal. We want to take every barrel and we want to maximize it to its highest and best use. And to do that, you have to have a very efficient network so that you can take water from one producer and aggregate it in a certain area and stage it, and then take water from someone else and put it somewhere in a different area, and then bring all that together for one large, well completion pad.
So, when I think of midstream, I think of like a gas midstream or oil midstream, right? Where they're moving product from one point to a destination place. We're moving it 2 different directions.
We are. And what you think about is certainly a component of what we're doing in terms of water midstream. But what we're doing is much more complex because we're moving it in multiple directions. And it's not always just from point A to point B, like more traditional gas midstream or oil midstream. It's from point A to point B, but oftentimes those volumes change, those rates change. You're going to have to divert it. You're going to move it here. You're going to move it there. And it comes down to you're not just moving the commodity to an end refinery on the coast to get processed. You're moving it around in basin to make it as efficient as you possibly can. And so that way you're not just trying to gather every barrel to dispose of it. You're gathering barrels to decide, should we dispose of it? Where should we dispose of it? How should we dispose of it? Should it be in a disposal well? Should it be beneficial reuse? Should we reuse that barrel? Can we reuse that barrel in the same field with the same operator? Do we have to move it to a different area of the field with a different operator? How can we be as efficient as humanly possible, or using technology, to make sure that we're using every barrel, we're reducing our operators' costs, and we're allowing them to be to produce more oil or gas at a lower cost.
So it's almost like a recycling business, right? Where you're using the same product over and over and over. The more times we touch the water, the better off it is, the better it is for everybody.
The better it is for everybody. And that's really the rise of recycling. If you think about water recycling, yes, it's environmental. Yes, it's the right thing to do from a governance or sustainability standpoint, but it makes the most financial sense. I mean, it saves operators money, and every day they're waking up trying to save money. And we're able to help them do that through recycling. And so it's really a convergence of issues that have allowed that created this recycling opportunity. And we're certainly at the forefront of it. We're trying really hard to build the largest water recycling network, certainly in the Delaware, but really across the country, to make sure that we're saving our customer money, we're being a better steward of the water, and we're able to make a profit in doing that.
Last year, I think we announced where we recycled 50 million barrels of water at our SCR facility.
That was in a partnership with Oxy, and it's something we're really, really proud of. I think what's interesting is if you think about that announcement last year and then the one we had a couple months ago, we reached the same milestone, also with Oxy, but at their Lost Tank facility in New Mexico. We did it in about half the time, which tells you a couple of things. First of all, from when we put in the Oxy facility in the Midland Basin, it was 3 years earlier than the one in the Delaware, and that's how much the market has changed. So in the Delaware, yes, you have higher water cuts, which certainly allowed us to reach that milestone faster, but the facility is much more integrated. We're tied into more operators than we're tied in the Midland Basin, and we're certainly tied into 3 operators, 4 operators in the Midland Basin. So it's not that it is a standalone facility for one customer, but it doesn't have the same level of interaction and the same network system that we have in New Mexico. And that's why we were able to reach the same 50 million barrel recycling milestone in half the time.
Do you think we're going to continue to see those numbers go down? We're going to do it faster? We're going to have larger recycling facilities?
I think the facility we put in last year, or really Q4 of 23, we'll reach it even faster. I mean, we're striving to be as efficient as we can with every single barrel. We're striving to reuse barrels rather than dispose of them. And again, the operator wants us to do that. They are saving money when we do that. And so having operators tied in, connected to us, and they're just saying, look, manage my water. You take it. You know where it needs to go. Charge me the minimum amount you can. And when I need water, bring it back to me and charge me the minimum amount you can. And that's what we're doing. So we're setting up pricing structures with the operators, and they are entrusting us to manage their water, to take the produced water and get rid of it, and then to give them frack water. And by give them frack water, they're looking for treated produced water. And that's really the model that we've employed. And so we can dispose of it, yes. But again, it's more efficient, it's more cost effective to recycle it. And the more people you have connected to a system tied in, the more optionality you have. The more chances you're going to be able to draw produced water at reasonable rates to meet frac demand. And that frac demand, whether it's a small 4-well pad or it's a giant 8-well pad with quad fracs. I mean, the rate required to go down hole continues to escalate, and it means you have to have bigger pipe, and you have to have more access to produced water and more storage. And that's really what we're focused on, Danny.
Think about what you said, a small 4-well pad.
It gets back to the evolution of the industry. I mean, we were changing so much, and in ways that we really couldn't have anticipated. I mean, I think back to some of the first people who put, meaningful water infrastructure in the Midland Basin is primarily the operators. Those assets are undersized. I mean, all of them are undersized today. So the assets we're putting in, I think they are oversized for the demand we see, but the reality is they'll still probably be undersized in a couple of years.
That was going to be a question I was going to ask is, we've got some of the early ones that were built, right? And they were a certain size. And now some of the newer ones, you look at them, you're like, oh my gosh, that's huge. How are we ever going to use that? But it seems like they're just going to continue to get bigger.
The water problem continues to grow. There is more and more push to avoid disposal and move towards recycling. And part of that's a cost because it's cheaper to recycle a barrel than it is to dispose of it. Part of it is, induced seismicity associated with some deep disposal wells. There's a lot of reasons why recycling makes sense. But just beyond that, the volume of water that we're managing on the production side and on the frac side for completions continues to increase year over year. And the volume of water the industry is managing continues to increase year over year. And so that's the water problem, and it continues to grow, which is why the infrastructure needs to continue to grow, and which is why you need to have more connection and cooperation between operators so that you can find a place to put that water and really dispose of it in a last case scenario.
I have so many questions going through my head right now. Just real questions that,
Well, that's why we're here, Danny. That's our job.
No, the size of the interconnects, right? What were we doing? 12-inch pipe? How big were the pipes we were originally laying, and how big are they now? How much have they changed there?
The system I'm thinking about that was put in a number of years ago by an operator is primarily an 8-inch system.
Wow.
I mean, an 8-inch system now is going to be a small gathering line for us. We're putting in 22, 26-inch pipe in a lot of places, 12, 16 inches in others. I mean, it really depends on where it is. And we're really focused on kind of a hub and spoke model. So you're going to have a couple of main artery lines throughout a region or a system.
Okay.
And try to have kind of a northwest, east, south. And then you can branch off that with smaller diameters. Sometimes, you'll have a distribution line and a gathering line. It's hard when you have a single line. I mean, yes, you can move water north or south through a single line, and you can rig it up that way, but you can't move water north and south at the same time. And when you think about a complex system, to your point earlier, you are moving water in multiple directions at the exact same time. And so that's the kind of redundancy that we're building in to make sure that when our customers call and say, we need this, our answer is yes. I mean, I think we have a recycling facility with an anchor tenant operator who will not draw water out of that for frac for 6 months, which is remarkable. And it gets back to they're putting produced water into it every single day, and we're finding the need or the demand for that frac water from other operators. So they continue to contribute. Now that's going to flip, and they're going to take all that water, and we're going to have to find produced water from other operators to support and supplement their need. And it's something that we do really every day. I mean, that's what we think we're good at. And I'd go back to technology. You're not able to do this unless you have automation, real-time visibility, remote and automated controls. And then you're gathering data points along the way so that you can start to get to predictive maintenance, predictive failures, build in the appropriate redundancy, know if there is an issue. I mean, we certainly hope there's no issues or leaks or spills or anything like that, but if there is, we want to know immediately. And it gets back to, yes, there's certainly a manual piece, and you can drive lines, but it's way more efficient to use a drone to check those lines or leak detection. And that's another area where we're really relying on technology to make sure we're providing the highest and best service we possibly can.
And, technology, Oilfield wasn't always known for their technology.
No,
right? We've had a huge resistance for that, but it's an everyday thing for us now.
We're becoming more comfortable with it. We're adapting it more on the front end. And we certainly have some customers who are happy to jump in there with us and say, look, we know everything's not going to go perfectly. We love this technology. We want to be your partner and figure it out. And so I am thankful for the operators that have supported us and co-developed products with us, because it makes them better, it makes the industry better. And I just go back to, you have to have it to accomplish what we're trying to do. I mean, the volumes of water, the rates are just too great. and it's becoming increasingly complex really by the day. Feeding off of that, one of the first things I think about is how can you be more efficient? And so being more efficient to me, in part, is being smarter. How do you see data management and leveraging technology and automation as a part of that process, Danny?
The volume of data we're seeing is growing exponentially. I mean, used to it was just we're tracking, how much water we're transferring, things like that. Now it's the chemical makeup of the water we're storing, where is it going? I mean, the volume of data it's growing exponentially. I was talking to somebody yesterday thinking about AI. How do we leverage AI to help us figure this out, right? We're looking at, okay, what fracs went off at what time? How did they push? When did we need the water versus what we thought it was going to be? How can we leverage artificial intelligence to help us do this better, right? We're starting to build out things like our ROC, our remote operations center, where we have a centralized view of everything that's going on between disposals, treatments, transfer, chemistry. That still requires a lot of human interaction. Mm-hmm. So where is AI? That's going to be the next generation, I think, for us, is how do we take and harness AI to help us predict some of this, right? Just like you do predictive maintenance on vehicles.
So what do you think of, so I understand the remote operations center. I mean, being able to visualize and control an entire water network from a single room with a couple of people, like that makes a lot of sense to me. That is efficient. That is full control, full understanding, real time, and efficient management. When you start to introduce the AI concept, like I just lose my mind. Like where does that go? What does that look like from your perspective? When do you think that will start to become, a bigger part of our operation or the industry?
So AI, there's a thing called a hype cycle, and it's kind of at the peak of inflated expectations where it's a Ginsu knife, it can do everything. It's going to fall off, and there's going to be some reality coming out of what it can really do. And I think it's happening faster than it used to. It's more for, how do I know what's going to happen, right? How does it predict, give us insight into things that are going to happen? Where am I going to possibly need this water?
So maybe guardrails to prevent manual mistakes.
Yep.
Or human errors.
Yes.
And then indications to predictive failures or trends in terms of, hey, let's start looking in this area. There's going to be a problem or whatever. That's how you see it getting implemented?
I really do. I mean, we have a lot of history on how long things have gone, when things have broken, right? And you take all that information. How do you get your predictive maintenance on your trucks? Based on history, track history. Well, our industry is changing so much and things are moving so fast that you can't wait for those old ways of doing it. You've got to let this artificial intelligence look back at historical data and do the analysis and predict where it's going to happen.
You want to fix it before you have the downtime.
Fix it before it happens.
Yeah,
absolutely.
That makes total sense.
Absolutely.
What about the value of the data? Like, how many data points are we capturing today? How do you? There's predictive analytics. What other value can you extract from that data capture?
You look at what we collected 2 years ago. This is exponentially more. You look at what we're collecting next year. It's going to be significantly more than what we have now. One of the things that I was talking to some AI guys yesterday, and one of the things I told them is, how can this data tell us where we need to put the next facility? Where do we need to put the next interconnect? Using this data to tell us before we need it, this is where we need to go next. This is the next opportunity for you. That's where I think a lot of this data is going to help us grow.
That's interesting, because as I take it back to kind of water midstream and really the evolution, I mean, it kind of started with just a single disposal well. And then you went to connecting a couple of disposal wells. And that was really where the value is going from one to many, because you had the redundancy and the ability to take on peak capacity. And then it moved to kind of more of the pipes. And I'd say recycling is somewhat akin to a disposal well, for the sake of this argument. But today, I think so much of the value is in the pipes in the system and the network. It's almost less about that single unique asset, the disposal well, the recycling facility. It's about the ability to move water real time where it needs to go. And so if you control the water, if you manage the logistics, if you can do that efficiently, that's where the real value is. And so that's kind of what we're focused on, is how do we how do we make sure that we can move all the water through as diverse geography as we can to meet as many customers as we can? And it's becoming less about those individual unique assets, the disposal or recycling facility, that used to be the focus of water management. And to the extent that we can use technology to help us leverage that, and where we need to go, when we need to go there, when we're going to have an issue, I think that's really kind of the next phase, or whether it's where we're today or where we're headed from kind of a water management standpoint in terms of infrastructure.
We've talked about the benefit, the water, reusing produced water. We've talked about, we can put it at disposal. What about beneficial reuse? Where do you see that? Is that really viable? Do you see that coming to fruition in the next 2 to 3 years? Is it sooner?
It will definitely be one of the tools that we in the industry are using within the next couple of years. It has to be. I don't think there's enough disposal capacity to where you could shut recycling down and dispose of all this water without creating environmental hazards, whether that's seismicity or surface breaches or whatever. I just, particularly, specifically in the Permian, I don't think there's enough. So recycling is a very clear part of it. But recycling's not the only part. At some point, completion activity starts to roll, and you're going to have more produced water coming back than you're able to recycle. And so preparing for that's going to be important. So you have the in-basin disposal, which we and others have today, and that's a clear part of it. You've got increasing interest in distant disposal or out-of-basin disposal, and I think that will be part of the solution. But the reality is, whatever concentration issues you're having with in-basin disposal, you're ultimately going to have with out-of-basin or distant disposal. And so that's really extending the runway, if you will. And then the other solution is beneficial reuse and environmental discharge. And that's going to have a higher price point, certainly, than in-basin disposal or recycling. But the market's going to get there either through just sheer demand supply economics or through some sort of regulatory incentives. We're very focused on it. We've spent well over $10 million trying to evaluate that. I think it's the single largest R&D project we've ever had. So we're getting really closer kind of by the day. But it will absolutely be a part of the solution. You're going to need really all four of those: recycling, in-basin solution, disposal solution, distant disposal, and beneficial reuse. And then as you think of that as a pie chart over time, I believe that the beneficial reuse will continue to grow. In part because it seems like to be a more sustainable solution, but also because there are ancillary benefits associated with that, whether that's, what you can do with the water in terms of, rangeland restoration or, aiding to municipal or industrial markets. I mean, longer term, these are water poor regions. We're operating in deserts. And so if you can create water and create economic rent and value in that geography, that city, it's going to really change things.
So you've got all these inputs and outputs and water coming from produced wells and trucks, and then you've got to send it out. How do you manage that? I mean, that's a lot to manage.
It's really complex, and again, you need the technology piece, because without that, it's manual, and you're doing a lot of guesswork, which is really hard. But just from a logistics standpoint, so just kind of picking an average well in the Delaware, when it first starts flowing back, you're going to get 15 barrels a minute. In a year, that's going to get cut down to 5 to 7. So it's a lot of water, but it's a relatively small amount when you think about the needed frac rate at 100 barrels a minute. So you need a lot of wells that you're aggregating over an extended period of time. You have to build up that storage to make sure that you have enough water to go in at 100 barrels a minute to support a completion.
So how long can we store this water? I mean, we can't store it indefinitely, can we? I mean,
what you have to worry about storing the water is making sure you maintain water quality. And if you store produced water for an extended period of time and introduce fresh water, or you don't control the bacteria, you can have bacterial growth, which will create real challenges and create challenges for your oxidizers going to frac. But if you continue to keep it up and recirculate the ponds, introduce oxygen, and other oxidizers, you can store it for an extended period of time.
So that's
but
why you want to
not indefinitely.
Well, you want to have more people connected, right? So you're
You want to
moving that water.
You want to move the water in and out, and because every time you move the water, you're creating a revenue opportunity.
That's not bad.
You're solving an opportunity, a problem for the customer. But yeah, the more water sits, the bigger the challenge is. So if you're not gonna reuse it, you need to send it to disposal. But our model is to try to reuse as much as we can, and we have the network we've created that allows us to move water pretty extensively to multiple operators so that we can keep that cycle going. And again, it goes back to you want to make sure you have enough water impounded to meet a frac, but if that frac doesn't come, that 5, 10, 15 barrels a minute continues to climb, and you got to go somewhere. So it really is a complex problem that you're trying to solve, and it's one that we've really embraced. Just because we think that the industry needs this solution. And so, that's a big part of our water infrastructure. It's a big part of the growth we've seen, and really trying to build out kind of the recycling, the gathering, the distribution, and the disposal piece, so that when an operator says, hey, I've got a water problem, doesn't matter if it's produced water, doesn't matter if it's frac water, it's a problem. We can say, yeah, we understand. We've got the lowest cost solution for you. This is how we're going to handle it, and give it to us. And then the piece I'd add on top of that is we still have the service component. So we're very focused on the water infrastructure. That's been our primary growth driver for the last couple of years, and I think will continue to be. But that service piece really allows us to complete the solution. So, I use this analogy. It's probably a bad analogy, but it makes sense in my head. Amazon does not want to own trucks. They have no interest in trucks. But to give you frictionless joy and to get you your package the next day, they got to own the trucks. So we have to own some trucks. We have to own the water transfer. We need that to provide a flexible, scalable, temporary solution so that to get the water where it needs to go and to take it away. Because you can't build permanent pipe infrastructure for every solution. It's just not cost effective. You can't build a 16-inch pipeline to every pad in every basin. So that's still a big part of it. And what we want to do is we want to solve the water problem, which is absolutely water infrastructure. It's the cheapest, most reliable, most cost-effective way to move water. But we also need the service for the scalability and flexibility to complete the solution.
Are there any operators or anybody is everybody on board with this recycling? Or do you still see some people going, hey, no, I just want to go to disposal. I don't care about the beneficial reuse. I don't care about the recycling. Just want to put it down whole.
I'd say that you saw that when the push was purely ESG driven. Some companies were more focused on ESG than others. Now that really brings an economic benefit to it, operators want to save money. They want to produce more oil and gas at a cheaper price. And if recycling allows them to do that, they're all in.
So is that where they're just telling us, hey, I've got this water, you do something with it and charge me the least. You do whatever's going to cost me the least.
That's right.
I don't care how you get rid of it. You want to recycle it. You want to beneficial reuse. You want to dispose of it. You want to sell it to somebody else. Just make it go away. Make the problem go away.
That's why we've seen the growth in the recycling we have, is because it is the lowest price solution to make the problem go away. And the problem being sourcing frac water in the desert or getting rid of produced water in an area where there's limited disposal or high cost of disposal. So that's why we've seen that kind of rise and that increase. And then as I roll that forward, when you look at beneficial reuse, that's going to have a higher cost solution, but you're going to get to a point where that's the market. And so I think when that becomes the market, operators are going to be largely indifferent, or some of them will be, as to whether you're disposing of it or reusing of it in a traditional sense.
Now the beneficial reuse, we've got a salt problem, right? And the desalination; those are expensive projects. Mm-hmm. Do we still have that issue with the beneficial reuse, or is there some way we're finding a way around that?
If it were easy, we'd have it done and it'd be commercially viable and all over the place. So there's a number of issues. Managing the salt, certainly one of them. It's not by any means the only one. What I would say is the solutions that we're pioneering, and others are too. I don't want to pretend that we're the only one. There are 2 or 3 other people that I think are doing a pretty good job as well. They are going to address the issue. I think, me personally, a partial desalinization is the best answer. So you're taking 1 barrel of produced water, you're getting half a barrel of highly concentrated brine that you're injecting into a disposal well, and half a barrel of distilled water. And so that seems to be the cheapest and probably the easiest way to manage some of the constituents, such as salt, that create a challenge with taking a barrel to full distilled. Because at some point you got to manage the salt, and you start to get to diminishing returns in terms of energy and other costs to create that. So there's a couple of different ways. I mean, there's thermal distillation, there's membrane solution, there's a combination of the two. One of the things that we certainly look at is just leveraging our chemistry team in our lab. We have a world-class lab here. We're very fortunate from that. We've got a really good chemistry team. The chemistry team is really important for taking that produced water barrel and making it compatible on the frac side. But the chemistry team is also really helpful for us in oil field recycling as well as beneficial reuse. Because there's a lot of pre-treatment that goes into beneficial reuse. And for oil field recycling, there's certainly a chemical component. And so being able to leverage that team, their relationships, access to chemicals and raw materials, leveraging the lab to make sure we know what kind of water we're dealing with on the front end, what that water looks like initially after we treat it, what it looks like in 30 or 60 days to make sure that we have, we know exactly how that water will change, if it will change, and we can make sure that what we're doing to it positions it best for its end use, again, whether that's beneficial reuse or reuse in frac.
And that's kind of cool that we have our own team that can do all this for us, right? Because you've got to solve this problem whether you've got it in-house or not.
It's a really nice vertical integration, and we're certainly fortunate that we have that. They do a good job, and it's such a logical combination because chemistry is absolutely a part of it. I mean, a lot of times the water is the problem, the chemistry is the answer. And so it's been helpful for us, and one of the reasons we've been able to expedite the growth around recycling we've had. And I think it's been helpful, and one of the reasons that we're where we are in terms of beneficial reuse solutions.
How do we know when we're finished in a basin? How do we know when we've built enough infrastructure, enough pipe? I mean, does it ever end? Do you ever get to the point where, okay, we're good here, let's go move to the next basin? I mean, or we're not building just one basin at a time, but still.
No, I mean, that's one of the things that I like is we're active in every basin. We've got infrastructure projects in every basin. We see an opportunity, and we're trying to help solve it in every basin. In terms of when you're finished, I think the market will kind of tell you. I mean, you're going to have inventory starting to dwindle, and you're going to see when that starts to roll, and you'll say, okay, the infrastructure we've built is enough for the forecasted development. Now, the one caveat I have is something we talked about earlier, which gets back to this industry is very innovative, and we continue to find ways to make wells that were uneconomic, 5-10 years ago, highly economic and productive today. And so as you think about, well, what will kind of core tier 1, tier 2 inventory look like in this basin in 5 years? Well, it's going to be substantially less than it is today. I mean, it might be zero, but at some point, the tier 2 and tier 3 inventory is going to get pulled in and have economics that are comparable to what the core tier 1 was initially, just because the completion techniques continue to improve and the cost continues to get driven down. So getting back to your point, there's not a definitive answer that by 2030 this basin will be fully built out. I mean, it might be, but it might not as well. And so we're carefully monitoring kind of volumes and forecast schedules of all of our customers as well as remaining inventory. And that's a process that gets refreshed regularly so that we always have at least a good outlook, not a perfect outlook because schedules change, but a good outlook of what's coming down the pike at us.
Are all the basins adopting recycle, reuse? I mean, is it something we see everywhere, all customers, all basins?
That's a good question. You don't see it with all customers in all basins. Every basin is unique. That has its own challenges, and the water problem looks different in each basin. The Marcellus and Utica have been doing a really good job of reusing produced water for a long time, probably more than Marcellus and the Utica. The Permian is really caught up here in recent years and is very bought in, and all the customers are bought in to water reuse and recycling there. The other basins, we've seen it in every other basin to some degree. And I think you will continue to see it increase more and more. The state of Colorado just passed regulations requiring more and more reuse. And I don't remember exactly, I think it's 2% starting in 2026 and 35% a couple of years thereafter. Some other states are looking at some similar things. They're encouraging, they're pushing, they're requiring. And so you will see reuse continue to grow in all the basins. It'll just grow at different rates because the water relative to oil, the water-oil ratio in the DJ and Niobrara is materially less than what it is in the Permian, in the Midland or the Delaware. And so you don't have the same volume of water available to support completion activity. Or another way to think about it is you need a lot more wells. So if you're a 1-to-1 or half a barrel of water to 1 barrel of oil, like you are some places in Colorado, relative to 2, 3, 4, 5 to 1 water to oil in the Permian, you need a lot more wells. And so it really makes it more challenging to accumulate enough water to support large frac programs, which is why the reuse targets there, the ones the states have implemented, and certainly the ones the operators have, are just less. Now, I think over time that will continue to build and grow. And to get back to your original question, is everyone doing it? No, everyone's not doing it. Do I think that over time it will see increased adoption in all basins, and ultimately you'll get to a point where the vast majority or all the customers are doing it at some point? Absolutely. And that's something we're focused on. That's why we like our presence in every basin. That's why we're working on water solutions, whether it's disposal, recycling, sourcing in every basin.
How do you see regulation changing? How do you see it helping the drive to recycling and reuse?
Forecasting what the government's going to do is not one of my areas of expertise. But I will say that I think you will see more regulation encouraging or requiring water recycling and reuse. I think you will see more regulation discouraging certain forms of disposal. I mean, you're seeing that already with the seismic reduction areas and seismic investigation regions. So you're getting that. I think that will only continue to increase. You can see, whether more curb use of fresh water. So I think that's kind of on the water side where we see a lot of the regulation changing. From an industry perspective, I'm not sure what else is going to change. What I would say is that regulation generally presents an opportunity for companies like Select because it poses a challenge. It changes the rules of the game. And our job is to solve challenges and to make things more efficient. And so as things change, it creates new opportunities for us to think creatively and to provide new solutions to, again, help our customers produce more at a lower cost.
So do you think they're gonna really regulate and say, hey, you have to use recycled water? Or do you think they're gonna do like the SRAs where they say, hey, you can't inject as much downhole and just let it organically happen?
I think it's gonna be all of it. I mean, really? I think it's gonna vary based on the state, first of all. I mean, the politics of some of the blue states are very different than the politics of the red states. And so that's gonna be part of it. I think so there's gonna be some issues where, municipalities or various regions get involved and treat things differently. So I really we're kind of prepared for everything, and we're just going to see what comes our way. But again, as long as we're focused on more oil at a lower price or more gas at a lower price, we're going to be aligned with our customer, and we're going to have the right solution.
Michael, I appreciate your time. These are a lot of questions I've had. I've been wanting to ask. I feel like I know a lot more about where we're going with our infrastructure business and kind of what's driving us to get there. And I really appreciate you taking the time to talk to me about it.
No, of course. Thank you for having me, Danny. This has been great. I'm really passionate about it. I'm passionate about what we're doing at Select. I'm passionate about the industry, so I love talking about it. So thank you for having me. This has been great.
Thank you, everyone, for joining us for Oilfield Water 360. We'll see you next time.